Happy Monday. It's great to see you. I'm so excited to get started with this week. This is some of my favorite chemistry that we're going to jump into this week. So we're going to get started with something I like to call the Stoichiometry Road Map. So we're going to really introduce the idea of what is stoichiometry and how does it work. And you're probably wondering, I have no idea what stoichiometry is. So let me just give you an example and we'll work through it together. Okay, so over here I have a chemical reaction. We're going to take solid zinc, we're going to react it with hydrochloric acid. It will react and produce zinc chloride and hydrogen gas. Okay, and you can see that I already have it balanced. I have 2 hydrochloric acid moles or molecules that produce zinc chloride, and there's 2 chlorines because of the charges, and H2 is a diatomic gas molecule. So everything's balanced, we're ready to go. It's a single replacement reaction. What we're going to do today is we're going to be able to predict how much product we produce based on how much reactant we start with. That sounds pretty cool. So if we really want to end up with 100 grams of, or 100 grams of hydrogen gas, how much zinc and how much hydrochloric acid do we need to put together to produce that? So let's check it out. Over here we have the Stoichiometry Road Map. And today you are going to have a short Google quiz where you're going to tell me about the Stoichiometry Road Map. But we're going to explain it all right now, so don't worry. Okay, so if we have compound A, and so for our example, I'm going to assign compound A, that's going to be the hydrochloric acid. Okay, and I'm going to say compound B is going to be the hydrogen gas. So how much hydrogen gas is produced when we add some amount of hydrochloric acid? Well, let me show you. On the Stoichiometry Road Map, which you have access to on Google Classroom, we are going to be able to convert hydrochloric acid into hydrogen gas. For example, if I say that there's 15 grams of hydrochloric acid, and I need to figure out how many grams, that's a question mark, how many grams of hydrogen gas we produce, here's what we would do. We start with the grams of hydrochloric acid, and we convert those 15 grams, the mass, into the moles of hydrochloric acid. And the way that you do that is we know that 1 mole is equal to whatever the molecular mass of hydrochloric acid is. So it's equal to the grams per mole, or the molecular mass. So you'd have to calculate that. We did that last week, and I know you know how to do that. Then we need to convert the moles of hydrochloric acid to the moles of hydrogen gas. And here's how we do that. We know that from our formula, 2 molecules of hydrochloric acid react and form 1 molecule of hydrogen gas. So we can extrapolate, or we also know that 2 moles of hydrochloric acid react and form 2 moles of hydrogen, or 1 mole of hydrogen gas. So we take the number of moles and we convert those to the number of moles in our balanced equation. Okay. So you have to balance your equation first before you can convert from moles of hydrochloric acid to moles of hydrogen gas. And the only way we can do that is by taking that coefficient. So there's 2 moles of hydrochloric acid to 1 mole of hydrogen gas. Okay, and then our final step, because we're trying to get to grams, we need to convert to the mass. And the way that we do that is we know that we need the molecular mass, the grams per mole. The molecular mass that we find on the periodic table, that the molecular weight, the number from the periodic table, where the units are grams per mole, we can convert from moles to grams. And then we've calculated the molar mass or the mass of hydrogen gas that is produced in the reaction. And actually, there's a whole bunch of different ways that we can do this. If I gave you, instead of 15 grams, if I said instead I have 10, let's say 10 times 10 to the 45 particles, that many particles of hydrochloric acid, a bunch of particles, and I want to know particles, and I want to know not grams, but I want to know how many liters of gas, because that makes more sense. What's the volume of gas? And I want to know that in liters. We couldn't start with mass because you didn't have mass, and we can't start at volume. We have to start at particles. And so to convert from particles to moles, we have to use Avogadro's number, or the number in a mole. How many is a mole? So we'd use the number 6.02 times 10 to the 23 particles, or number of things per mole. And I have this written really nicely in the road map that I've linked on Google Classroom. We take the number of particles per mole, so we can convert this many particles to this many moles. And then, using the same step, we'd go from moles of hydrochloric acid to moles of hydrogen gas. And then finally, in this step, we'd convert, instead of going to mass, because I don't want mass, I want liters, I want volume, we'd go to volume. And actually, what we're going to do is we're going to say 1 mole of anything is equal to 22.4 liters at STP. And you see STP and you go, what in the world is that? STP stands for standard temperature and pressure, and that's just the regular temperature, regular pressure that exists. Okay, and so we're just going to assume that 1 mole is 22.4 liters. And that's how you do it. And then the same thing goes over here. If we had some type of gas as a reactant, we would use the same conversion here, where 1 mole is 22.4 liters at STP. And the same conversion here that we used, number of particles, from moles to particles, we know that 6.02 times 10 to the 23 number of particles is 1 mole. Wow, my handwriting is not great, but that's okay. So I know this is a lot to take in. You're like, what in the world? Let's do an example problem, okay? So what we're going to do as an example is I'm going to give you, let's just say 40 grams of hydrochloric acid, and I want to know how many total particles, how many total number of particles of hydrogen gas will we produce? Okay, well, how in the world am I going to figure this out? It's okay. It's going to be a piece of cake. We'll walk through it together. So we start over here with what was given, 40 grams. Okay, and I'm going to erase this real quick, but that's where we're going. 40 grams. We start out with 40 grams of hydrochloric acid, and we need to convert this. If we have the mass, we need to first convert to moles, because we're trying to get down to here, the particles of hydrogen gas. But we're all the way over here. So our first step is to convert to moles. We'll use a unit conversion, and because grams are on the top here, I'm going to put grams on the bottom here so they'll cancel out, and we're going to convert it to moles. Do we know a relationship between grams per mole? Yeah, it's the molar mass found on the periodic table. I looked it up. It's 36.5 grams to 1 mole. 1 mole is 36.5 grams. The next thing that we need to do is convert from moles of hydrochloric acid to moles of hydrogen gas. So, I know that we have 2 moles of hydrochloric acid for 1 mole of hydrogen gas. So I'll just write that. Because this is moles of HCl, we'll put moles of HCl on the bottom. We know that that's 2. And we'll put moles of hydrogen gas on the top. And we know that's 1. Now that we've converted moles of hydrochloric acid into moles of hydrogen gas, we're so close. We're almost there. We need to convert the moles of hydrogen gas, moles of H2, into number of particles of H2. And so we convert moles to number, and we do that by saying that 1 mole is equal to 6.02 times 10 to the 23 number of things. And in this case, it's number of hydrogen gas, particles. And so actually, this is all the work. And now we just use our calculator and plug this in. And here's how we're going to plug it in. We're going to take 40 and we're going to divide by 36.5 because it's on the bottom. And I haven't pressed enter yet. I'm going to look at the next step. I'm going to divide by 2 because it's on the bottom. And then I'm going to multiply by 6.02 times 10 to the 23 because it's on the top. So I press multiply, 6.02 second EE 23, and I get 3.29, well, let's just say 3.3 times 10 to the 23 particles of hydrogen gas. We get 3.3 times 10 to the 23 particles of hydrogen gas. And that's how you do each step. If we're going somewhere else, you use the different conversion factor. Awesome, you guys did a great job today. I know it's kind of tricky, but we're going to practice it throughout the week. So, what I need you to do with this information is to take that Google quiz. Also, I'll see you at 11 if you have any questions, but remember, the Google Hangout is totally optional, so if you think you got everything down and you got other things to do, there's no need to log in. But for those of you who have any questions with chemistry stuff or any science stuff, let me know. I'll be there at 11. Have a happy Monday, and I'll see you the rest of the week.